So this pen cast is going to be on square roots and cube roots. The thing to remember with square roots is that a square root is the inverse or opposite of squaring a number. So in example A, where I see the square root of 36, the first thing I'm going to do is try to write 36 as the square of some number. And I know that 36 is 6 times 6, which means it's 6 squared. So I can rewrite this square root of 36 as the square root of 6 squared. Since the square root and the power of 2 are opposites or inverses of one another, they cancel each other out. So the square root sign and the power of 2 cancel, and what I'm left with is 6. So the square root of 36 is 6. In example B, I have the square root of 49. Once again, 49 is 7 times 7, which means it's 7 squared. So I can rewrite the square root of 49 as the square root of 7 squared. And the square root and the power of 2 cancel, leaving me with 7. In example C, we have a fraction, but both the numerator and denominator are perfect squares. So I can rewrite the square root of 25 over 144 as the square root of 5 over 12 squared. Because 5 to the power of 2 is 25, and 12 to the power of 2 is 144. Remember, when we see the power of 2, that means we're multiplying that number by itself twice. So 5 squared is 5 times 5, which is 25. And 12 squared is 12 times 12, which is 144. Now, once again, the square root and the power of 2 cancel, leaving us with 5 over 12. Example D asks us to take the square root of -4, and it is tempting to write that that must be -2. But remember that we're taking a number to the power of 2. So what we're really saying is, can we take some number to the power of 2 and get -4? Well, if I take -2 to the power of 2, I get 4. I don't get -4. So when we see a negative sign under the square root, there's no real solution. So we just write not real. If you take the next algebra course, Math 169, you'll start talking about what are called imaginary or complex numbers, and that's when we can deal with those negative signs under the square root. In example E, it asks for the square root of 0. Well, if we think about it, 0 squared means 0 times 0, which is still 0. So we can write the square root of 0 as the square root of 0 squared. Now, once again, the square root and the power of 2 cancel, and we get 0. So the square root of 0 is 0. Once you understand square roots and the fact that square roots are just canceling out powers of 2, then it's easy to do other roots as well. So cube roots work the same way. They're just going to cancel out powers of 3 rather than powers of 2. So sometimes this is easiest to do with prime factorization first. So if we take 8 and we want to know, is 8 something to the power of 3, we'll just break it down into its prime factors. 8 is 2 times 4. I circled a 2 because it's prime. And 4 is 2 times 2. And I circled those. So 8 can be rewritten as 2 times 2 times 2, which is 2 to the power of 3. So I can rewrite the cube root of 8 as the cube root of 2 to the power of 3. And now the cube root and the power of 3 will cancel, and I'm left with 2. Let's do the same thing for example B. First we'll take 125 and break it down. 125 is 5 times 25. The 5 is prime, so I circle it. 25 is 5 times 5, and I circle both of those. And now I can see that there are 1, 2, 3 factors of 5, so that's 5 cubed. So I can rewrite the cube root of 125 as the cube root of 5 to the power of 3. The cube root and the power of 3 cancel, and I'm left with 5. Now, if we look back up to the top, in example D, we saw that you cannot take the square root of a negative number. Doesn't work. But with cube roots, if I think of negative 64, well, if I write negative 4 times negative 4 times negative 4, negative 4 times negative 4 is positive 16, and 16 times negative 4 is negative 64. So negative 4, in parentheses, to the power of 3 does give us negative 64. So there's an answer to this one. I can rewrite this as the cube root of negative 4 to the power of 3. And now the cube root and the power of 3 cancel, and that gives me negative 4. So one thing to remember too is if we look at square roots, we never write it down, but square roots have what's called an index of 2. Cube roots have an index of 3. So you might want to think to yourself, what's the difference here between a square root and a cube root? And maybe try some further examples using even indexes and odd indexes. And you'll probably notice a pattern there. In example E, we have the cube root of 0. Well, once again, 0 is kind of a special case. We can write 0 as 0 cubed, because all 0 cubed means is 0 times 0 times 0, which is still 0. And then the cube root and the power of 3 cancel, and our answer is 0.